So as a final improvement, right, to the IMP programming language, we will try to add pointers to the language. Okay. So pointers are kind of a quintessential feature, right, of C such language, of C-like languages, right. So let's see what will happen if we try to add pointers to IMP. So we are going to add two more programming statements. So one is a pointer dereference, right. So here we are dereferencing the pointer variable y, right. So x colon equal to star y means that you are dereferencing the pointer variable y, and you are storing the value that was stored at the location y into the variable x. Okay. And you can also assign using dereferencing, right. So star x equal to e means that you are again changing the value that is stored at the address that is given by x, and the new value should be given by the expression e. Okay. So the star has the same kind of semantics as in C-like languages. Okay. So now what is the effect of these two program statements? So let's see a program which contains these statements. Okay. So let's consider this following piece of code. Okay. So let's look at the code first, and then we will look at the precondition, the postcondition. Okay. So what does this code do? It's a sequence of assignment statements, right? So it first says that x is equal to y, but x and y here are pointer variables, right? So then it says that star y is equal to 3, star x is equal to 2, and then z is equal to star y. Okay. Now if you are aware of how pointers work, right? So by doing this x equal to y, essentially, right, I mean you can think of a cell in the memory, right, and that cell in the memory is pointed to by both x and y. So both x and y point to the same cell, right. So so now when you do something like star y is equal to 3, the value 3 is going to be written into this particular memory cell, and when you do star x is equal to 2, since x points to the same location as y, right, because you are doing x equal to y, so x points to the same location as y, therefore this value is going to be overwritten by 2. So therefore when you now read through star y, right, so when you do z is equal to star y, you are dereferencing the value that is stored at this memory location, but that value has now changed to 2, right. So therefore now let's look at this hold triple, right. So this hold triple is saying that if you start the precondition is true, the post condition, right, z is equal to 3, is this correct or not, right. So does this program satisfy the specification, right. So in this case, as we have seen, right, due to the semantics of pointers, right, this program doesn't satisfy the specification, right, because x and y are both aliases, right, they both refer to the same memory location, and therefore even though you are seemingly assigning 3 to star y, and then you are reading, right, z equal to star y, because of this intermediate assignment statement, right, star x equal to 2, star y will no longer contain 2, right, sorry, it will no longer contain 3, right, it will contain 2. But the issue is that if we were to use our existing rules, right, then we will not be able to say that this program is incorrect, right. So remember that what do our existing rules do, right. So for assignment statements, right, if you look at weakest precondition, for example, for assignment statements the weakest precondition just works by substitution, right. So the z is equal to 3 will be propagated backwards to the program, right. In this formula z equal to 3, when you have this z equal to star y, so it's going to propagate this to backwards, right. So it will change the formula to star y is equal to 3, and then it will propagate the star y equal to 3 backwards. So when it does star x equal to 2, at this point, right, this star y is different from star x, right. So that's not going to change, right. So we will have something like star y equal to 3 again. So the weakest precondition of star y equal to 3 with respect to this assignment statement will remain star y is equal to 3, right, because weakest precondition doesn't know, right, that x and y are actually the same location, right. So now we will propagate the star y equal to 3 backwards through this statement. So you will get 3 is equal to 3, which is the same as true, right, and therefore you will get true itself, right. So in fact if you compute the weakest precondition, right, of this z is equal to 3 with respect to this entire sequence of statements, you will get this to be true, okay. But this is not correct, right, because we know that this particular specification doesn't hold, right, this program is actually incorrect. So we need new rules, right, for assignment statements involving pointer assignments. And the way we are going to do it is we are going to use the theory of arrays for this purpose, right. So we are going to treat the memory as a giant array M, right. So let's say that I have this memory array M, right, and we are going to use the pointer variables as indices into the array, okay. So in fact, this is what the semantics of pointers are, right? So pointers are actually memory locations, right? So they point to memory locations, right? And we are going to make this explicit by having a memory array and using pointer variables as indices into the array. Okay. So something like x equal to star y, right? The star y is a pointer variable, therefore it's also an index into a memory array, right? So this statement is going to become x colon equal to m y, right? So m y meaning you are indexing the array m at the index y, right? So you're finding out the value that is stored in the memory array m at the index y, right? So we are essentially making the semantics of pointers explicit, right, by saying that a pointer is just an index into a memory array, right? Similarly, the star x equal to e, when you do star x equal to e, you are actually changing the memory array, right? So you are changing the memory array by modifying the value at the index x, right? So this will be given by this particular, so here we are using the theory of arrays, right? So we are saying that the memory array m has now been modified, right? So this particular notation, right, which we had used when we introduced the theory of array, this means that the memory array m, right, the value at the index x is given by this particular expression e, right, and this new memory array m, where only the value at the index x has been changed, this is now assigned to m, right. So essentially this means that the memory array m itself has changed, and the change is only in the index x, right, where the value of the index x or the value that is stored at that index x is equal to the expression e. Okay. So once you do this particular transformation, right, so again this is a program transformation, right. So wherever you see pointer variables, you are going to introduce the memory array m. Right. So once you do this, now you can just use our existing verification procedure. So you can use, so now you can treat this as normal assignment statements, right. So these are now normal assignment statements, and you can use our existing formulations, right, for normal assignment statements. So in particular, if you have something like x equal to star y, right, and you want to show some post condition q, right, so we want to find the weakest precondition for q for x colon equal to star y. This is the same as the weakest precondition of q, but I am going to replace this now with a memory array indexing, right. So this will be x equal to my, right. And now this I am going to treat as a normal assignment statement, right. So this is just going to be equal to q, where m of y is going to replace x. Okay. So q, where wherever you see x in q, you are going to replace it with m of y, right. So this will be the weakest precondition. Okay. Similarly, for star x equal to e, right. So if you want to find the weakest precondition for q and then star x equal to e, so again this is going to be the same as weakest precondition of q for this particular assignment statement, right, m equal to m, where x, the value of x is changed to e, right. And now we are going to treat this as a normal assignment statement, right. So therefore this will be the same as q, where this m, this modified array m, right, modified array m is going to replace m, right. So wherever you see m in q, you are going to replace it with this modified array, right, where this modification is only done to the index x. Okay. So wherever in the formula q, wherever you see m, you replace it with the modified array. Okay. And that's all, right. So now let's again look back our previous code, right, and see does it work now, right. So if you use our new formulation, right, for handling the pointer assignments, right, will it work? So again we are going to propagate this backwards, right, but when you see this z equal to star y, right, so now here, right, in the formula z equal to 3, you are going to replace every occurrence of z with m of y, right. So you will get m of y equal to 3, right. So this will be the weakest precondition here, right, and then star x equal to 2, right. So again, right, we are going to propagate this m of y equal to 3 backwards through star x equal to 2, right, which means that we are going to now change this memory array m, right. So at this point m will become m, where x has the value 2, right, and in this particular memory array, in this modified array, we are asking whether or not the index y is it equal to 3, right. So all we have done is, wherever you see m, right, this is how we are handling this star x equal to e, right, where wherever I see m, I am going to replace it with this modified array, right. So, here there is one occurrence of the array m, I am going to replace it with the modified array, and the modification is obtained by saying that the value at the index x is now equal to 2, right. Similarly, for the star y equal to 3, we are now going to so we are going to replace m with the value y, the index y, the value is 3, okay, and then we have x equal to y. So, which means that wherever I see x in this entire formula, I am going to replace it with y. So, there is one occurrence of x which is here, so I am going to replace it with y. So, I am going to ask, okay, is this true or not, right. So, this is the one, this is the VC that will be generated, right, where does true imply that m, where at index y you are storing 3 and then at index y you are storing 2, indexed at the location at the particular index y, is it equal to 3, right. So, now we ask the validity of this particular formula modulo the theory of arrays, right. So, if you recall in the theory of arrays, right, we had seen things like read overwrite and read overwrite 1 and read overwrite 2, right. So, in particular, right, we know that this write, right, this is going to overwrite the value, right. So, we are essentially first modifying the value at index y to 3 and then you are modifying the value at the same index y to 2, right, which means if you in this array, right, if you then read the value at index y, it is going to be 2, it is not going to be equal to 3, right. So, this was according to the read overwrite axioms that we had seen, right, because the latest write is going to overwrite the previous write, right, to the same index y. So, therefore, this is not, so this is going to be not valid, right, modulo the theory of arrays. Right. So, since this is not valid modulo the theory of arrays, therefore, this VC is also not valid and therefore, we will say that the Hoare triple is also not valid, right, which is what we wanted, right. So, because this particular Hoare triple is actually not valid, right, the program is not correct, okay. So, this is how we can model pointers, right, by essentially using the theory of arrays, right, and converting pointer assignments to through to array variables, okay. Okay. So, with this I am going to stop today, we will continue in the next lecture.